Good day to all of you. Today we shall discuss on model question paper 1 202324 of the subject Digital Design and Computer Organization with subject code BCS302. Question number 4c, which is asked for 7 marks. Define decoder. Describe the working principle of a 3:8 decoder. Draw the logic diagram of 3:8 decoder with enabled input. Realize the following Boolean expressions using a 3:8 decoder and multi-input OR gates. F1 of ABC equal to sigma m of 137, F2 of ABC equal to sigma m of 235. Solution. A decoder is a combinational circuit that converts binary information from n input lines to a maximum of 2 raised to n unique output lines. Its purpose is to take n inputs and generate 2 raised to n in bracket or fewer minterms. Okay. So it's a combinational circuit in the sense it will be made up of logic gates. Right. So in combinational circuit, the output at any instant depends only on the inputs present at that time, not previous outputs. Second point. Then it will not have any memory elements. It will be having only logic gates. So decoder is also combinational circuits. It does take n inputs and generates 2 raised to n unique outputs. The number of outputs may be less than 2n also. So n to m line decoder it is called. N to m. If n inputs are there, m will be 2 raised to n or lesser than that. So unique output lines means if n equal to 3, 2 raised to n means 8. 2 raised to 3 is 8. So for 3 inputs, 8 output lines will be there. Unique output lines means any one output line will be at logic high. All remaining will be at logic 0. So that is what is unique. This is in case of active high. Only one line will be at logic 1. In case if the circuit is active low, any one output line will be at logic 0. All remaining will be at logic 1. That logic 0 whatever is there, that is active. That is in case of active low circuit. So general term we use asserting. So in case of a decoder, any one output line will be asserted. Okay. So next we shall see 3:8 line decoder. So this figure shows 3:8 line decoder. So 3:8 line means here 3 inputs are here and 8 outputs are shown here. M0, M1, M2, M3, M4, M5, M6, M7 are the output lines. They will be generating 8 minterms. So first minterm is M0. So this is decimal 0. With 3 bits it is 0, 0, 0. So x dash, y dash, z dash. So M1 means x dash, y dash, z. M2 means 0, 1, 0. That is 2. 0, 1, 0 means x dash, y, z dash. M3 means 0, 1, 1. 0, 1, 1. X dash, y, z. M4 means 1, 0, 0. 1, 0, 0. X, y dash, z dash. M5 means 1, 0, 1. 1, 0, 1. X, y dash, z. M6 means 1, 1, 0. 1, 1, 0. X, y, z dash. M7 means 1, 1, 1. X, y, z. Okay. So these minterms will be in terms of that input literals x, y, z. So 8 outputs means 8 AND gate should be there in that 3:8 line decoder circuit. Okay. So now how to give connections to these 8 AND gates so as to generate these minterms. Generating that minterm means M0 means when inputs 0, 0, 0 are given, x is equal to 0, y equal to 0, z equal to 0, then only M0 line will be logic high, all remaining will be logic 0 in this case. This is active high circuit. This is made up of AND gates. This is active high circuit. If it were NAND gate, it would be active low circuit. In that case, only this line would be logic low. All remaining lines would be logic high. Now, it is logic high, it is made up of AND gates. So that kind of 3:8 line decoder we are considering. After drawing 3 inputs here and 8 AND gates, how to draw remaining circuit? So X, Y, Z, these are X, Y, Z. So X is coming here, Y is coming here, so this Y, then Z is coming here. 3 input lines are taken. Next, from X through NOT gate, X dash will be coming. That second line is drawn, that is X dash line. So from Y through NOT gate, Y dash is coming. This fourth line is Y dash line. From Z through NOT gate, Z dash is coming. The sixth line is Z dash line. So this first line is X, second line is X dash, third line is Y, fourth line is Y dash, fifth line is Z, sixth line is Z dash. Okay. This way both X, Y, Z and their complement lines are made available. Now here M not equal to X dash, Y dash, Z dash line means X dash, Y dash, Z dash lines must be connected here. So this is X dash line. So from there here X dash is connected. Next Y dash line. So this is Y dash line. Y dash is connected. So this is Z dash line. Z dash is connected. Similarly for next one, M1 equal to X dash Y dash Z dash means this is X dash line that is connected. This is Y dash line that is connected. Z means fifth line, that is Z is connected. So this way connections are done to all the AND gates. Next, enable input is given to all AND gates. When enable is 1, this decoder will work like decoder. If enable is 0, then one of the inputs to all AND gate is 0. When any one input is 0, output is 0. Output of all AND gates, hence all minterm lines are 0. Then it is not working like decoder. Okay. If enable is 1, so it depends on other inputs. Hence, for those minterms, only that line will go asserted. So that is what is 3:8 line decoder with enable input. Okay. So here if it is 2 to 4, only XY 2 inputs, then X line, X dash line, Y dash line. Instead of 8 AND gates, we'll have to draw only 4 AND gates. Then first minterm would be M not equal to X dash Y dash. M1 will be 0 0 0 1 X dash Y. M2 will be 1 0 means XY dash. M3 will be 1 1, that is XY. Only those inputs would be given, and that is how we would draw logic diagram for 2:4 line decoder. Similarly for 4:16 line decoder, 4 inputs we draw here. Instead of only X, Y, Z, one more we include W. Okay, instead of 8 AND gates, we have to draw here 16 AND gates. And what would be M naught? W dash, X dash, Y dash, Z dash. So here W through NOT gate, W dash, 2 extra lines would be here. And the procedure for making the connections is same. Okay. So figure shows 3:8 line decoder. It has 3 inputs X, Y, Z and 8 output lines M0 to M7. In decoder at any time, depending on inputs, any one output line will be asserted active if EN is 1, enable input is 1. Here any one of output line is logic 1 depending on input combinations, that is X, Y, Z values. If X equal to 0, Y equal to 0, Z equal to 0, then only output M0 is 1 and so on. Okay. So that is all about 3:8 line decoder, what logic diagram we have drawn and explanation regarding that, and in general what is needed for 2:4 decoder or 4:16 decoder, those points we have added here or we have discussed here. Okay. Next, to realize the given Boolean functions using 3:8 decoder. The given Boolean functions are f1 of ABC equal to sigma m of 137, f2 of ABC equal to sigma m of 235. So this is 3:8 decoder block diagram. There ABC are the inputs, that are 3 inputs, and 8 outputs are M0, M1, M2, M3, M4, M5, M6, M7. Any input combination if given here, only one output line will go high. So here when input combination is 0, 0, 1 means M1. So what is it is in binary? 0, 0, 1. The decimal is 1. So M1 line only that goes high. Suppose if combination is 0, 1, 1, that is 3. Only M3 will go high. If combination is 1, 1, 1, then only M7 will go high. So M1, M3, M7 are chosen and they are given as input to 1, 3 input OR gate, and the output will be F1 of ABC equal to sigma M of 137. Means here we will get logic 1 output for any one of these input combinations. That is what is implementation of F1. Similarly, Boolean function F2. Here minterm 2, then 3, then 5 are taken logically ORed, and at the output we have F2 of ABC equal to sigma M of 2, 3, 5. Because only for these input combinations, here 0, 1, 0 that is 2, 0, 1, 1 that is 3, 1, 0, 1 that is 5. So minterm 2 line, then 3 line, 5 line will be 1 then, and hence they are chosen and logically ORed. Hence we will have logic 1 output at those minterm combinations. Okay, that is what is the implementation of F2 of ABC equal to sigma M of 2, 3, 5. Okay. So with that we come to the end of discussion of question number 4c, which is based on decoder, in that 3:8 decoder with enabled input and realizing two Boolean functions using 3:8 decoder. This discussion can be extended to if decoder is of 2:4, if n is 2 here inputs, outputs 2 raised to 2, 2 raised to n it is 2 raised to 2, means 2:4 it will be. If it is having 4 inputs at the output side, 2 raised to 4, 16 output lines. Here they have asked 3:8, or there may be 2 to 4 or 4 to 16. That is first one. Next one, if they ask to implement any Boolean function, we have to observe the biggest number here, minterm number. They may not have given A, B, C, only F1. Then we have to identify on input side how many inputs are there. So biggest minterm we'll have to see. Here it is 7. To represent 7 we need minimum 3 binary bits. If you take only 2, we can represent 0, 0, 0, 1, 1, 0, 1, 1. 1, 1 means 3. The maximum minterm we can represent is 3 with 2 bits. With 3 bits, 8. With 4 bits, 16. Suppose in the function 13 is there, we'll have to take 4 input variables. Then if you take n equal to 4, on output side 2 raised to n, that is 2 raised to 4, 16 output lines will be there. Then to implement that Boolean function, we'll have to choose 4:16 decoder. Okay. So then if it is having 0, 1, 2, then 2:4 decoder is enough, because maximum minterm if it is 2, it can be represented with using only 2 bits. Then on input side only 2 inputs. Then n equal to 2. 2 raised to n means 2 raised to 2 is 4. Then 2 to 4 decoder is enough. Suppose if they have not given, if it is not mentioned, then to realize that Boolean function, we have to see to the maximum number of minterm here. Depending on, we have to choose how many input lines are required, and that will fix up decoder size. Rest all procedure will be same. Okay. And while drawing logic diagram also, 3:8 means 3 input lines, 8 output lines. Because 8 output lines, 8 AND gates will have to draw. 2 to 4 decoder means 4 AND gates. 4 to 16 means 16 AND gates. And remaining procedure what we followed, that is same. Okay. So that completes the whole general discussion on decoders. I hope you understood. Thank you.